Okay, so hello everyone and welcome to the Emerging Media Lab's 2022 Annual Spring Showcase. Today we will be showcasing all the projects our teams have worked on throughout the entire school year. Thank you all for joining us during this busy time near the end of exam season and for coming out to our first in-person showcase event in 2 years. So my name is Virginia and I'm the Marketing Communications Assistant at EML. It's an honor to be one of your co-hosts for this afternoon, and I'm looking forward to guiding you through the exciting things we have on the agenda today alongside Josh, who I'll let introduce himself now.
Hi everyone, my name is Josh and I'm the lab coordinator at the EML. I'm thrilled to be one of your co-hosts for this afternoon, and we are looking forward to showing off all of the amazing projects that our hardworking project teams have been working on this entire year. Before we begin, I would like to acknowledge that UBC Vancouver is located on the traditional, ancestral, and unceded territory of the Musqueam people. The land it is situated on has always been a place of learning for the Musqueam, who for millennia have passed on their culture, history, and traditions from one generation to the next on this site.
Thank you for that, Josh. Now I'm just going to go over some important housekeeping points before we dive into talking about the projects. So this meeting is being live streamed and recorded to be posted on our online channels, so please just keep that in mind. Feel free to think of any questions and comments and just keep them in mind for our Q&A at the end of the presentations. If you're watching online, please put any questions into the chat on Zoom. And then please just make sure your phone is turned off so that we can limit any distractions during the presentations. So now we're going to get started.
To kick off our showcase, we'll be starting with opening remarks from UBC's Chief Information Officer, Jennifer Burns, and Associate University Librarian and Director, Julie Mitchell. UBC IT and IKBLC have helped shape the EML, and we are extremely appreciative of their support over the years. I would like to ask Jennifer and Julie to share a few words before we begin project presentations. First up is Jennifer Burns, Associate Vice President, Information Technology and Chief Information Officer at the University of British Columbia. Reporting to the Provost and Vice President Academic, Jennifer provides leadership, ensuring the institution's digital capabilities meet the needs of UBC's teaching and research community, as well as identifying opportunities to deliver efficient and effective administrative solutions. During her time at UBC, the Emerging Media Lab was launched, working with faculty, staff, students, and commercial partners to use augmented and virtual reality in the classroom and for research. As well, UBC has undertaken strategies to advance a vision of a digital future, supporting the implementation of its strategic plan. Jennifer views technology as a strategic enabler to university's vision of creating an exceptional learning and research environment. Her work as the CIO is guided by the values of integrity, transparency, collaboration, and excellence. And here she is.
Thanks, everyone, and thank you for that introduction. So this is a very 2022 problem. So I'm wearing glasses that I don't usually wear, and so if my glasses start fogging up, it's the mask. I never thought I would have to acknowledge that. So I'd like to thank you all for coming today and for giving me an opportunity to speak before you get started. And I know everyone really wants to get to the cool tech part. I'd also like to acknowledge the work of Syed Dinakar. I'm not sure if he's here today or not, but I know that he always takes great pride in these sessions and really being able to display to the community the work that's done. So I think he's here with us remotely. So I remember last year giving this introduction with Simon Bates and doing it by video and saying at the time how much that I would hope that in the future we would be able to all come back together and do this in person. And we are able to do that today, although with the face masks, I know we would have all liked to have had a chance to see each other without those. And so hopefully that's the next step for next year. This spring showcase is one of EML's flagship events. It's an opportunity to connect with all of you, to show you the work that's happening, and really importantly, expand your opportunity to think about what other kinds of projects that you might be able to bring forward. This work is possible because of the students and the faculty that bring ideas forward and give us an opportunity to work with them on the projects and to be able to display them in the future. We've had another really amazing year of success. When I think back to when this started in 2017, we could not have imagined how successful it would be and how much students and faculty, our librarians and others would really have embraced this new technology. And as we can see and look to the future, it's becoming more and more relevant, not only for teaching and learning and research, but in daily life. And we think about the conversations that have started around the metaverse and that small m metaverse versus the capital meta as Facebook has become. And really what EML is here to do is to really be that incubator of ideas and thinking to really drive us forward as an institution in the use of these technologies. And it's directly aligned to UBC's strategic vision, which is transformative learning as set out in our strategic plan, which I know all of you have spent a lot of time reading online. And, you know, one of the things that happened very early in that really, I think, helped the momentum was the winning of the Cuccio Award for Innovation in 2018. That really told us we were on the right track, that other institutions were looking at what we're doing. And I know that the EML and Said have hosted other institutions that are really interested in what we're doing here and want to think about how they can do that themselves. And so I really have to congratulate the folks who every day make this work. You've been online when everybody else went online, and now, of course, we're coming back and learning how to work in a hybrid model. Not an easy thing to do, and so we're trying to figure out how that all works, and I think you guys are really leading the way. Key projects that have been done have also underscored the importance of this work, and I'm thinking about HoloBrain and the 3D metabolism learning through augmented and virtual reality. Those set the bar and help us think about how, you know, a hybrid world might look like. And, you know, one of the questions I posed to Said is, can we think about hybrid meetings that way? Can we think about what it might be like and how we might actually make that work in a more connected and distributed campus environment? So all kinds of ideas out there, and I really encourage you to all keep thinking about that in the next while as we navigate our world, and how do we operationalize that beyond teaching, learning, and research as well. And one of the things that is great about EML is the collaboration and partnerships, for example, with UBC Library, Center for Teaching and Learning Technology, our commercial partnerships, and partnerships across with faculties. We would not have and be where we are today without those partnerships and engagements. And so I think it's one of the things that makes the EML so incredibly unique. And I think it's really important for me that UBCIT can be partners in that, because it's a way that we can contribute to the learning mission and also to our research mission for those various activities. So for today, we have some amazing projects to unveil. So the 3D Metabolism Project that looks for a novel way to understand and visualize information contained in the famously difficult to learn metabolic network. And we also have Oer Geomatics, which enhances geomatic teaching and learning at UBC through an interactive click and discover textbook. That sounds amazing. And we also have Geospatial audio, which allows users to hear the pronunciation of the Musqueam language signs around campus, which allows you to do that by scanning them with your phones. As well, Moot Court is a simulator that captures the real experience of a real-life moot court. And so for those of us who thought that the tech aspect of this was really limited to the STEM sciences, we'll show you otherwise today. You're probably already aware that technology has the opportunity to disrupt and rethink many disciplines, and we have projects collaborating with the Department of Theater and Film, the Department of Biochemistry, and Archaeology, and much more. So whatever you're interested in, we have something for you. And to date, we've successfully incubated 37 projects, many of which are well known and used to advance VR and AR in the higher ed ecosystem. So I'd like to close today with letting you know how you can become involved with the EML. Faculty and students are encouraged to submit proposals related to their teaching, learning, or research projects that use emerging media technology, including but not limited to virtual reality, augmented reality, and artificial intelligence and machine learning. So lots of options there. And we're currently accepting project proposals for the September 22 to April 23 term. And students are encouraged to join EMLX, which is the student group within EML that aims to explore and experiment with different technologies. And that's a great opportunity for students to gain new skills and to try something different. And so finally, I'd like to thank all of the students and the faculty and the staff involved with the EML. You are incredibly passionate. You are the ones responsible for driving this forward. I think UBC and UBCIT have given you a framework to do that, but we would be nothing without the passion and enthusiasm that you've all displayed in making this work. So congratulations, and I hope all of you enjoy today and have a chance to really see the great work that's been happening, and maybe it will spark an idea for some of you in going forward. So thank you very much.
Thank you so much, Jennifer. Here to also say a few words is Associate University Librarian and Director of Irving K. Barber Learning Center, Julie Mitchell. Julie provides strategic leadership and oversight of the Irving K. Barber Learning Center, including the Chapman Learning Commons, Program Services, and the Center for Writing and Scholarly Communication. She is responsible for the planning and development of public spaces in the Irving K. Barber Learning Center, especially as they relate to supporting student programs and services. Julie also focuses on enhancement of the Learning Center's province-wide community engagement efforts through innovative programs and partnerships, both off and on campus. Passionate about student learning, evidence-based practice, and innovative applications of technology in the library environment, Julie is an advocate for student needs and strives to develop library programs and spaces that foster interdisciplinary interaction and create a sense of belonging in the academic community. So I'll pass it over to her.
Thanks, everyone. Wow, this is my first in-person event since COVID, and actually the first time I've been in this Pena room, which is we renovated just before the pandemic. So I was thrilled with the opportunity when it came along in 2019 for Irving K. Barber Learning Center to partner with UBC Studios to create an EML space in the Irving K. Barber Learning Center. It had actually been a dream of mine for several years prior to create this type of space in this building, but I'd never really figured out how to make it happen until I started talking with Saeed Yanitkar, and then we both really developed an excitement about having an instance of EML here in Irving K. Barber. It may strike some people as odd for a librarian like myself to take interest in a space and program like the Emerging Media Lab. A lot of people, when they think of libraries, think of repositories for books. But it's actually, academic libraries are at the forefront of providing technology-enabled space that supports learning and research. So it's particularly exciting for me to see how the partnership with the Irving K. Barber Learning Center and the Emerging Media Lab has flourished over the last couple of years. In fact, shortly after the Emerging Media Lab opened in March of 2019, another project that we got started on with UBC Studios was creating a DIY media studio, which is located actually just on the third floor here in the Music, Art, and Architecture Library. So this is a sound buffered studio that enables library users to create high quality audio and video recordings, kind of like a podcasting space. And it has access to microphones, dual microphones, which are great for interviews, a mixing board, video camera, a green screen, and various video and audio editing software. And so the DIY Media Studio is extremely popular, and it's actually used in a Land and Food Systems course, Duncan McHugh's course, LFS 400, and they use the space for the students to do interviews with researchers. So it's really exciting for us to see how it's getting integrated in courses and being utilized by students and faculty. But ultimately, the DIY Media Studio, which is another technology-enabled space here, wouldn't have been possible without the library's partnership with the Emerging Media Lab, UBC Studios, and also, of course, IT. More recently, my colleagues Rochelle Mazar and Alan Cho have been working with Catherine Winters to look at how we can, hi Catherine, utilize the level 2 concourse of the Irving K. Barber Learning Center to showcase the great work that's happening out of the Emerging Media Lab. So you might have seen it when you were coming in here, that there's a demo set up on level 2. And so we've been looking at ways to really utilize that high traffic space to feature the EML's work. There's even discussions underway between the EML and the library to partner in helping people interested in emerging media and digital scholarship to find each other. Really just leveraging the existing relationships that liaison librarians have with scholars in the disciplines that they support. As another example, the Faculty of Arts and the Emerging Media Lab are working to provide more access to the library's newly acquired Shakespeare portfolio, which I'm sure some of you have heard of, and you may be aware that Dr. Patrick Pennyfather, who I think is in the back there, is working with the EML to digitally reconstruct the first folio. So really exciting partnerships that are underway. The Emerging Media Lab project was a priority for the Irving K. Barber Learning Center because it creates space for interdisciplinary interaction and it extends the reach of the EML to more people because this is a high traffic building, lots of people coming through, central location, and we're open really long hours. So I'm just delighted to have the Emerging Media Lab located in the Irving K. Barber Learning Center and look forward to seeing how this partnership continues to grow. So with that, I'll turn it back to you.
Thank you, Julie. Let's begin the project presentations. First up, we have 3D Metabolism. The project group includes Mohsen Movahidi, Joshua Yun, Ryan Saeed, Kim Nip, and Ella Gray. Before we hear from the student team, I'll first pass the floor over to 3D Metabolism's PI, Dr. Lindsay Rogers. Is she here? Okay.
I'm going to just start our slides. I think Ella and I are going to present. Does that work? There we go. Can I advance with this too? Yeah. Okay, thanks. Yeah, so I'm gonna just spend the first minute talking about this project, and then I'll pass on to Ella and Mohsen. But yeah, essentially what we're working on is an emerging media-based project to more effectively visualize cellular metabolism and support learning in that space. So for some of you that aren't biologists here, we define metabolism as kind of the entire collection of chemical reactions that functions within a really dynamic, complex network within sort of every cell in every organism to enable kind of every biological process. So it forms this really complex network, and it's kind of applied across a lot of fields of biology. So students learn metabolism first in high school, and then in biology and biochemistry and pharmaceutical sciences during post-secondary education, and also in sort of research settings and medicine. So we thought there was this huge opportunity to learn to use emerging media to really enhance and improve kind of how we can visualize and represent metabolism. So if we look over here at sort of the existing learning tools that existed before we began this project, we have sort of a couple options. So this is sort of a diagram of a metabolic pathway from a textbook, so a 2D image. And this is what we refer to as a metabolic map. So here we have kind of a visualization of the network, and here we have sort of just one pathway sort of isolated from this network. And really what we're trying to do is kind of combine the information, sort of the detail that exists here, as well as sort of the network representation that exists here, and also add some sort of exciting additional kind of features and functions that kind of bring this really exciting network to life. And we're doing that using emerging media. So we have sort of 4 project goals. The first is to recreate metabolic pathways in a 3D space. We're also working to kind of compile and sort external data from a wiki base that we've generated and then call that data to our network. And we're also adding a lot of UI features and functions that enable the user to manage complexity within this really complex network and also enable the user to visualize metabolic flux. So when I say metabolic flux, I mean sort of the flow of metabolites and reactions kind of as they flow through these pathways within our network. So that's a really brief introduction from me. And I'm going to pass off to Ella Gray next to discuss sort of project goals 1 and 2 here.
Okay, thank you for the introduction, Dr. Rogers. I don't actually know how to go to the next one. There we go, okay. So I am a subject matter consultant, and my job is to take pathways that are traditionally represented in 2 dimensions and convert them into a comprehensive and coherent 3D network. In our network, nodes represent metabolites, so that's like glucose and acetyl-CoA, and edges represent metabolic reactions. Edges connect to nodes to show how metabolites are converted through metabolic reactions, and in each cellular compartment, a metabolite is only shown once, and this allows us to show how a single metabolite can be involved in multiple different pathways and how interconnected metabolism really is. Okay, so if you look on the right of this slide, you'll see a traditional representation of glycolysis taken from a well-known biochemistry textbook, and next to it is our representation of glycolysis in Unity. Here you can see how we've represented metabolism in 3D space and how nodes and edges connect to form reactions that make up metabolic pathways. One of the most exciting things about our project is that it allows the user to appreciate the interconnectedness of metabolism. So you may notice that there's some extra nodes and edges surrounding glycolysis in Unity that aren't highlighted, and they're not part of the glycolysis pathway in the traditional textbook representation. These nodes and edges belong to other metabolic pathways that work in conjunction with glycolysis. So that means they might produce metabolites that glycolysis uses, or they might use metabolites that are produced by glycolysis. If you were limited to learning biochemistry from a textbook, you'd have to flip through pages in order to learn about these other metabolic pathways. But with 3D metabolism, it's all right there, and it's easy to appreciate how connected they are to glycolysis. Okay, so you might notice that there's some chemical detail that seems to be lacking from Unity that's seen in the traditional textbook figure. This information is found in the Wikibase. The Wikibase is an open source software best known for being the software behind Wikipedia. It can be accessed by the user to find all of the information that's not included in the Unity model. Each metabolic pathway has its own Wikibase page that contains a description of the pathway and all of the reactions involved, and clicking on a reaction opens up a new page that contains tons of supplemental information about that reaction. And together, the Wikibase and the Unity model contain all of the information included in a traditional textbook, but represent it in a much more connected and coherent way. Okay, I will pass on to Mosa now.
Thank you so much, Ella. All right, so I'm gonna talk a little about the tech stuff that's going on in 3D metabolism. I'm the software developer on the team. But before I start, I just want to acknowledge the work that our UI UX designer has done, Kim Nip, and also the work that our old software developer, who's now a supervisor over at the Cedar Lab, Dante Cerrone, has done. He's in the back. Hi, Dante. Yeah, without those two, like, none of this work would be possible. So thank you so much. But yeah, as my two colleagues mentioned, this is a very complex network that we're trying to replicate on this tech side of things. And we kind of need to let the user or researcher student to focus on a specific part just because how complex this is. And this is why we have the highlighting feature and the label feature. So as you can see in this small video, the user can choose the pathways they want to focus on. They can even choose only to focus on the specific one, so they can toggle the labels. They can say, okay, we have two modes of highlighting. One of them is yellow, one of them is blue. And the yellow version actually shows the directions of the reactions as well. So if they want to hyper focus on a few pathways, but they want one specific one to see how that relates to these other ones, they have the ability to do so. On the next slide, however, I want to talk to you guys about one of the integral part of our project, which is animations. And the reason we have animations in this project is we want to kind of visualize the flux through these reactions in a way that, like, you can't really see on a textbook. On a textbook, you can't really play a video, as you all know. And we kind of built this animation editor onto the Unity software, Unity being the engine that kind of runs all of this tech, which is called IET4U, which basically is this custom editor that any user can use to grab simple animations that we pre-make and kind of put it in a sequence. So for example, here, you can see that they're kind of like getting highlighted. There's a little wiggle, and it kind of shows the flux through this, which is called the mallet aspartate shuttle as part of the pathways. All of these are like tiny animations here, like stop wiggling, start wiggling, which is very simple for the user to kind of understand. But then once we sequence it, it creates this whole thing, which shows the reaction going through. But we kind of wanted to take this to the next step. And that required us to change our database. And as Ella mentioned, we have kind of 3 types of data types. So we have nodes, which are metabolites, edges, which is our reactions, and pathways, which are kind of like the groupings of these nodes and reactions together. And we had to create this hybrid graph. And for those who are not necessarily in computer sciences, graph is essentially a way to replicate network on a data sense, on a data backend. But this didn't really fit into a traditional set of definition for a graph. So we had to like actually consult with the Faculty of Computer Sciences, and we figured out a way to connect these. So the reactions hold connections for the metabolites in these data types. And I don't want to bore you guys with the details, but the nodes don't really hold any information other than the information about themselves, and pathways are the ones that connect the metabolites to the reactions. And this is how like the computer algorithm goes through. And this gives us the feature of custom animations. And custom animations is something that we're currently working on, where we actually, instead of us pre-making animations for the user to see, so if you press the button play and then it plays it for you, we actually let the user choose what animation to see. So they can choose any 2 metabolites on our network. So for example, they can choose this glucose up here and something down here, and the computer will automatically create the animation for them. So this is kind of like we give the customizability to the user. But yeah, I'm gonna pass it back to Dr. Rogers to send us on.
Okay, I'm just gonna finish. Thanks, Mohsen. So I'll just finish up with a few sort of mention of future direction. So we've been working on this project for almost exactly 2 years. The technical ability at EML is really amazing, and I think it's amazing how far this has really come in that time. But we are still working really hard on this project. So we have some directions that we're currently going. So importantly, we're still working on expanding our network. We sort of initially focused around carbohydrate or sugar metabolism, sort of as a proof of concept sort of place to start. We'd really like to expand the network to include additional metabolic pathways relating to sort of lipid or amino acid metabolism. Importantly, because it's going to be really exciting when we get this tool to the point where we can really effectively represent physiological states. So disease conditions such as diabetes or particular cancers, once we can really model and represent that using this tool, I think it's going to be sort of a huge step for us. We're also working to incorporate sound into the network, designing a website to host the tool, designing a lot of learning tools and other learning resources and other kind of instructional resources to support the use of the tool, and also sort of collecting some data as we implement the tool into classrooms. We're working on sort of a web-based application now, but eventually we'd like to expand into either an AR or VR version as well. And I guess we really like the idea of potentially using a similar approach to also visualize additional networks. So potentially neuronal networks or networks in computer science, or even sort of networks sort of in root systems and soils. So just to finish, I just want to acknowledge all the people that have supported this project. Particularly at UBC Studios, Saeed, Danikar, Kim Nip, and Michael Sider. We've had a lot of support from Emerging Media Lab, particularly from Dante Siran, Catherine Winters, Daniel Lindenberger, and the students on our team that have been sort of actively involved in the project this term are, where's Joshua? Joshua Yoon, Ryan Saeed, Ella Gray, and Mohsen Movahedi. Oh, and I also want to thank the UBC Teaching and Learning Enhancement Fund for funding this project.
Okay, thank you so much to the 3D Metabolism team for that amazing presentation. So next up, we have Oer Geomatics. So the project team includes Juno Yoon and Floria Gu. So before we hear from the students, I'll just pass it over to PI Dr. Paul Piquel to say a few words.
Hello, everybody. My name is Dr. Paul Piquel. I'm an assistant professor of teaching in the Faculty of Forestry, and I teach geomatics, which is the art, science, and technology of collecting and analyzing data and information about Earth. So quite a big topic. And the project that I'm going to introduce is this OER Geomatics textbook that we're working on. So OER is an acronym for the Open Educational Resources. So this would be an open and freely accessible textbook that we're trying to achieve here. So probably about 5 years ago, I dropped my initial paid textbook from my classrooms because I was really dissatisfied with the cost, and a lot of the existing content that's out there is very American-centric, and I'm an American, so I feel like I could say that. So a lot of content maps and stuff are oriented towards American problems, the United States context, and there's not a lot of really good content out there that's open and available for Canada. And as well, despite some of these online textbooks, and these are examples from two, the one on the right here, both of them, are just using very flat images, very two-dimensional images, despite being hosted online, which I thought was really, really disappointing. So my colleague and I, Evan Thornberry, who's the GIS librarian here at UBC, we set out to develop our own new textbook. We got funding through the OER implementation grant here from UBC to do that. And we started doing some of our own stuff, like creating just some simple web maps and other interactive content that we could get by on. And we recruited a bunch of graduate students to sort of help us get to that stage. But admittedly, it was still quite two-dimensional. And so this was the reason why we reached out to the Emerging Media Lab to help us work on some of those interactive elements and really take advantage of the full potential of that online user browser experience beyond just web maps and other kind of visualizations that we could do on our own. So with that, I will hand it over to Juno and Floria to introduce the great work that they've just been working on.
Thank you, Paul. So before we begin, our team consisted of our principal investigator, Dr. Paul Piquel, Evan Thornberry, and for our EML side, we had project lead as Juno Yoon, and staff developer as Dante Saren, and software developer as Juno Yoon, Floria Gu, and Kenny Zhao. And I'll pass on to Floria for the introduction.
Thank you, Juno. So this past term, our team created interactive visualizations to support 2 chapters of the textbook: the Geodesy Visualization for Chapter 2, Mapping Data, and the LiDAR Visualization for Chapter 15, LiDAR Acquisition and Analysis. A third visualization about the electromagnetic spectrum is also in ongoing development.
Thank you, Floria. So the main technologies that we used were React 3 Fiber and 3JS, which are used to create a online 3D content in the browser environment. We also additionally used Leva Control right here, which provided a intuitive side panel for the user to be interacting with the visualization. Additionally, for hosting our visualization, we used Amazon S3 Bucket, which is used to create a temporary link where the user can just click on it and access the visualization. This was used for internal testing as well as user testing. Now I'll pass on to Floria for the Geodesy visualization.
Thank you, Juno. Yeah, so this term, I worked on the Geodesy visualization. Geodesy is the science of measuring the shape, orientation, and gravity of Earth. One important task that students must learn is how to specify the height and location of points on Earth. So the coordinate systems that we use are actually anchored against reference surfaces, which are models that approximate the surface of the Earth. These models could be as simple as a sphere or as complicated as the geoid. And understanding the coordinate system is important because using the same coordinates could put you in 2 different places if you happen to use different coordinate systems. Now, since these reference surfaces are inherently in 3D, we thought that an interactive tool could provide a fuller appreciation of their differences than existing flat diagrams. So for this chapter, we created a 3D visualization around 3 models of Earth's shape: the sphere, the ellipsoid, and the geoid. Our goal for the geodesy visualization was to enable the students to explore the models in 3D to better understand their differences for referencing height and location on Earth. We also wanted to create a tool that instructors could use in class to guide discussions and encourage active learning. The primary features of the visualization are these 3D sphere, ellipsoid, and geoid models, which can be shown or hidden to compare against one another. Since the geoid surface is an irregular surface, we used a public data set of geoid heights to create this 3D model in Blender. Also, we added supporting 3D geometries, such as lines and points, to show how the latitude and longitude coordinates would interact with the 3 reference models. And lastly, the geoid height view is a restricted view that we implemented to visualize a specific concept in the textbook called the geoid height, which compares 2 of the models specifically, the ellipsoid and the geoid. Yeah, so in January, we tested this prototype with 5 students from the textbook's target audience. The students expressed that they needed more context to identify the models and connect them to the height differences that they were seeing, so we added legends. Also, it was important for us that the users are able to access the textbook from many different devices. For example, they could be using their phones during an in-class activity, which is why we created a responsive layout that is able to adapt to mobile screens. Okay, that's it for the geodesy visualization. Now I'll pass things over to Juno to talk about the LiDAR visualization.
Thank you, Floria. So before I go into technical details about the LiDAR visualization, I'd like to provide some background information about what LiDAR actually is. So LiDAR stands for Light Detection and Ranging Technology. For geography concept, LiDAR sensor is mounted to an aerial vehicle like this, which travels across the Earth's surface, and it emits a laser pulse and light signal. And the signal is then reflected and collected by the same sensor. This records the approximate XYZ coordinates and additional attributes depending on the setting of the sensor. The collected point cloud data is then used by the feature manipulation engine to process the data to a point cloud data. Once the data has been processed, that data could be used to create some visualizations. So the following are some example of visualizations written by the point cloud data. So the typical point cloud data like this, and right over here, consists of the XYZ coordinates, the intensity and elevation level, along with the number of points and the size of the points. So these 2 visualizations are the same visualizations. However, the one at the bottom does have a thicker density of points. Additionally, some visualizations here, you could see that they are different colors. So the one at the bottom represents the intensity in RGB. The one at the top right represents intensity in black and white. And one on the top left represents the elevation level in color. So to write such a visualization, it proposed several challenges. Number one was determining a way to process the point cloud data. Because the point cloud data came in a lot of different data formats, such as LAS, LAZ, and EPT, it also proved to be difficult to figure out exactly which format that we should be using. Additionally, as the visualization has a number of different customization abilities, such as allocating number of point budgets and allocating intensity color, those algorithms also had to be developed as well. And lastly, the controls involving camera in 3D environment proved to be challenging. To overcome such issues, we also reached out to another open source library called Pottery WebGL Point Cloud Viewer. This application is able to process widely accepted point cloud data formats and has several built-in functionalities, such as classifying different part of the point cloud, determining a method to allocate elevation level depending on the XYZ coordinates, and other customizable features such as camera controls and, different visualization view. So we converted our Pottery application to a React application. This provided a way for user to access the visualization without running a server on their end. Additionally, we implemented query parameters to enable the students to reach out to the visualization in exact format they require. As this visualization is to be used in a textbook format, the instructor could customize the URL with the exact parameters that they would like, and the visualization would be loaded in such format. By doing this, we made sure that the visualizations were interactive, intuitive, and ease of use. Additionally, our original prototype did not have a way for the user to manually change the visualization and the classification without the use of query parameters. However, after the user test, the users advocated a need for built-in controls, which we implemented using Leva control. Additionally, we also implemented a way for query parameters to disable the built-in controls so that the user would not be distracted from the primary purpose of the referencing from the textbook. This concludes our presentation for Oer Geomatics, and thank you for listening to our presentation.
Thank you to the Oer Geomatics team for a great presentation. Next, we have Geospatial Audio, presented by Olivia Chen and Vida Chan. Before we hear from them, I'll pass it over to PI's Dr. Daisy Rosenblum, who is unfortunately not here, but is in the Zoom chat answering questions, and Dr. David Garter.
Thanks very much, and thanks for the great presentations so far. It's so wonderful to be in a room with people who are doing such great work. So my name is Dave Gartner, and I'm one of two directors for CEDAR, which is Community Engaged Documentation and Research. And as mentioned, my colleague Daisy Rosenblum is joining us by Zoom, and we also have in the room Dante Cerrone, who's our new, we just snapped him away from EML to work over at CEDAR. And Sarah McClellan, who's just joined our team as well. So Daisy and I both work out of the Institute for Critical Indigenous Studies, Daisy in First Nations and Endangered Languages, and I work in First Nations and Indigenous Studies. We're sort of two halves that make up the whole of that space. And we sort of came together both because of the power of technology that we've seen in lending itself to cultural resurgence and survivance around language and storytelling in particular. So we came to EML originally with this idea about finding a way to connect language, technology, and storytelling in a way that could be situated and place-specific. So what we wanted to do, Daisy and I are both also have community radio backgrounds and are audiophiles. And so what we wanted to do was to create an application in which sound files, stories, poems, language could be connected specifically to certain places on the land. So using geo-triggers or QR codes, when you are on a specific place in the land, you would be able to hear an audio file that was attached to that. And so for our beta test for this, we actually worked with our colleagues in Musqueam Language and Culture, specifically Vanessa Campbell, to think about the Hunkamanum language, Hunkamanum street signs that you see around UBC now. So with the application that we've developed, which is the first of what we will hope will be many on this platform that we're building, what you can do with the app is you can scan the street signs as they exist, and then you can actually hear Vanessa Campbell from Musqueam pronounce the Hunkamanum right in your head. And from there, it'll connect you. We have 9 of the signs linked up around campus, and the application will show you where the other signs are, and you can hear all those different pronunciations. We're hoping to expand out of this a little bit more. We're also working with Vancouver's Poet Laureate, Fiona Lamb, to think about some place-based poetry projects that we'll be releasing later on. And there's some other language initiatives as well, too, where we're thinking about language as it exists, again, in relation to place. So we've had an amazing team on this, and we've worked with them over the year. And I think Daisy and I are both just thrilled with seeing this idea that we had last summer come into reality. So we're really excited to be here to share it with you. And so I'm going to pass the microphone on and let Olivia tell you a little bit more. Thank you, Olivia.
Yes, please. The fancy clicker. Thank you, David. So now that we've learned about the project inspiration, let me introduce the rest of the team. Oh, okay. So starting off with the wonderful PIs that we've just met, one of them, David and Daisy. And then you have me, the project lead, Olivia. And then in development, we have Dante, once again. He's been on every project so far. There's another one too, he's still on it. And then in design, we have Vita, right beside me. And in advising, we have Catherine Winters, Erin King, Hannah McGaugan, and Vanessa Campbell. And a special shout out to our honorary member, Joshua Lim, for helping us out with various different aspects of this project during this term. So considering the subject matter of this project, we would like to begin by acknowledging that the land on which we gather is the traditional, ancestral, and unceded territory of the Hunkaminam-speaking Musqueam people. Oh. Hello? Oh, okay, cool. So our approach to providing a solution to create an experience for our users begins with this overarching framework. So first, we took the images and the audio files from the Musqueam street signs at UBC's website, and we stored them in our custom Drupal interface as data. And in tandem, we also made a web application supported by React 3 Fiber, which is just a React framework that supports Three.js. And thus, we have a product, or in this case, rather, a proof of concept. I'll just use that.
Since for this project, we are creating both a database and an end product, there are two types of users we had to consider. So first was the editing users, which will be interacting with our Drupal database. But more importantly, there is a subcategory of editing users called authenticated users, which will be using the Drupal to mostly manage content. So for example, they would be responsible for inputting the information about the Musqueam street signs and where they're located, and also the audio files. And then next we have our end users, which are the people that will be using the end product. So again, they'll be going around campus and scanning the street signs and also using the application to navigate around. So one of the things that we have worked on this school semester was customizing the Drupal interface to allow our authenticated users to have an easier time of managing our content. So first thing we did was create custom content types called tours and locations. So on the image on the left shows what Drupal looks like when you are creating tours and locations. And basically within a tour, you have a set of locations which contains the associated information like coordinates and all the media files. We've also customized the interface mainly to address general usability concerns, like changing button labels to better reflect what they do, and also to better suit the tasks of our authenticated users. We've also changed the way that content is displayed on Drupal to allow better content management. So before, everything was just listed on one page, regardless of whether it was a tour or a location. But now, as you can see on the image on the right, it's a tour and the locations are listed within it. And there's also a map to see where everything is as well.
So seeing that traveling, and by traveling I mean foot walking, is an important nature of this project, we've created an entry as QR codes to the app. Oh, so we've created a QR code generator in our code base to have it be accessible from project to project. So each project can build their own QR codes inside the app and use them. So we've used image recognition to trigger the audio that corresponds to these street signs. The image recognition part is made possible with AR.js. So first we took these images from the Scrim street signs at UBC, and we trained them into NFT markers. NFTs in this case is not non-fungible tokens, but are rather natural feature tracking files, which are really good file formats for your cameras or your phone cameras to read. And then we took the cameras from 3JS to scan these street signs to trigger audio. Thank you. So now that we've touched a bit about audio, let me walk you guys through how we made spatial audio possible. So I've mentioned previously that we have NFT markers here and also cameras. So 3JS also is like reads in 3D by nature. So in this instance, when users put up their cameras up to the markers, which AKA are the actual street signs, the camera is able to tell where they are in relation to the camera. So by that, we could use positional audio to trigger like spatial audio events, which are also built inside 3JS.
So these are the features that we had planned on implementing for our end product. So far as the one that we have completed is image recognition of the street signs, which allows you to point your camera at the street sign and then play the corresponding audio. We've also implemented a map feature to help people navigate across campus if you're unfamiliar with the place, and also just letting users know that there are other street signs in the area. And then things that are currently a work in progress are the GPS triggers, so sort of providing feedback or notification if the user is within a certain radius of another street sign, and then also including geospatial or like spatial audio or background soundscape so that there's some sound as they're navigating between street signs.
So the priority of the project was to lay a foundation that would produce a minimum viable product. Therefore, most of the former components discussed took a while to solve because it's a level of difficulty and constraints on time. So most of our future plans include enhancements of currently existing components, as well as features we have yet to implement, such as the GPS trigger. Thanks for coming.
Thank you. Good job. Okay. Thank you so much to the Geospatial audio team for that amazing presentation. So our last presentation for today is Moot Court, presented by Veronica Chen, Olivia Chen, Vida Chan, Michelle Hun, and Rosaline Beck. So before we hear from the student team, I'll now pass it over to their PI, John Festinger, and Nikos, I believe.
Thank you. Hi, everybody. With me is Nikos Harris, a wonderful colleague who is Associate Professor of Teaching and Director of Experiential Learning at Allard. I'm an adjunct professor at Allard. In some strange way, this project is actually almost wholly born of the Emerging Media Lab. I attended, at the invitation of EML, a community of learning event last summer, where I heard a professor from University of Ottawa talk about something called exposure therapy and its use in dealing with patients who had undergone trauma, and the use of exposure therapy through virtual reality. If you were afraid of heights, you could fly in Microsoft Flight Simulator, and that exposure would make you less afraid of heights. So that naturally led to me thinking about what traumatizes law students the most and what traumatized me the most when I was in law school in 1976. And that's an exercise called the Moot Court, where you argue against a team of other law students in front of real judges. And with that, over to Nikos.
Yeah, it's an incredibly difficult experience for students in their first year of law school to be able to come in and not just give a presentation, but to 3 senior lawyers, and to be in a position of not just articulating their views, but being challenged on them. And that's actually the key to, I think, most discourse, but particularly legal discourse, is getting questions from the decision makers and answering them. And the law school sometimes thinks, let's protect everybody from everything. I think some really good ideas that John has been creating, let's expose them to this in an environment that is comfortable and safe, where they can start working out some of those stressful issues. And the idea became to create a moot court where they at any time could flip open their laptop, be in a very realistic virtual court with a judge, and practice their presentation, including being asked questions by the judge. And I think we thought this was something that was going to take years to put together. And our incredible EML team, I'll turn over to in a moment, has within 6 months very much brought this to fruition. I just want to mention its potential application. All first-year law students, I think, have to go through this Moot experience, and so being able to practice in a virtual environment will assist all of them. It's going to help our upper-year students. We do competitive Moots. I think it can help law students across Canada who have these same issues. I think it can help any student who's having to do a presentation to have a virtual forum, and I think it can help the broader public. We are currently in a crisis of access to justice. About half the people in court these days are representing themselves. That's incredibly intimidating. Having the chance to go into a virtual court and practice your presentation, as I think you'll see, we're able to program in specific questions to their case to be asked by the judge, I think could be a real assistance, not just to lawyers. I think lawyers could use the practice, but people representing themselves, a chance to get familiar with the court environment. I want to turn things over to and recognize Dante. We had the best team. I was a bit of a tech skeptic. I think that's why John told me I had to get involved. They were not about the tech. They were about creating a meaningful learning experience for the students, and that's what drove the project.
Thank you, John and Nikos. Hi, I'm back again. Don't worry, I'm just here to introduce the team. So starting off with our principal investigators that you guys have met already, John and Nikos, as well as Barber and Wayne, who aren't able to be here today, but is here with us in spirit. And we have our project lead, Dante Cerrone, once again. And in development, we have Michelle, Rosaline, and in design, we have myself, Vita Chan, and Veronica Chen.
So as Nikos has just mentioned before, mooting is one of the most stressful events of the first-year law experience. As such, our principal investigators wanted to create a tool that would simulate the experience, allowing students to practice their presentation and familiarize themselves with the process. So to best understand our students' mooting experiences, pain points, behaviors, etc., we conducted user interviews with upper year law students who have done moots themselves before. So that is online or in person. With these interviews, we were able to gather valuable research insights and qualitative data to best back our design choices and practices. So for features, we first have a landing page to welcome the users in, and then a home page where users can choose to access mooting resources, or start their simulated moot. Mooting resources include mooting procedures, oral presentation tips, and generally everything a first-year law student would need for a successful moot. We wanted this to be the go-to place where resources are centralized. And then in terms of starting the moot, we have the setup page, which I'm pretty sure my colleagues will dive into in detail in a bit, but here we can customize our mooting experience, whether you are the appellant, the defendant, whether your moot takes place during the daytime, nighttime, and generally whether you want a shorter time period for your oral arguments or a longer one if you're just new to the process. And so once you have customized your mooting experience, you will be brought into the simulated moot. The design of the interface. So the goal was to make a design that encourages and entices the first-year law students to use the app for learning and practice. So we wanted to have a UI that was very welcoming and non-intimidating. And then the UI elements, such as colors, branding, was made to adhere to UBC branding. The most complicated component in our app that is visible on the interface is the setup page, which we'll get into in a bit. Essentially, everything that a user checks or inputs in the options will directly reflect how the presentation component would be sent forward. So like I mentioned before, if you are the appellant, defendant, whether it's daytime, nighttime, et cetera, all the choices you make on the setup page will be reflected directly into the simulated moot.
Hello. Hi, I'm a developer for this project, and I'm going to explain the general structure of our application. So a lot of our projects that are hosted online on the web page, our project was also made using React, and the 3D models were rendered using React 3 Fiber, which is a React renderer for 3.js. So these are the 5 main components of the application, and these in our backend is defined as a JavaScript file that cleanly separates the responsibilities. It uses something called React use effect hooks to respond to application events such as change of time or a button click. The following are the tools that we use to create the prototypical project that we have right now. React 3 Fiber, as mentioned, was used to render the 3D models. In order to host this on a web page, we used AWS hosting. And in order to create a realistic judge, we used the following tools. Speech synthesis was used to generate the voice of the judge. Blender was used to generate the 3D models that set up the scene. And Deep Motion, Mixamo, and Plask AI were used to create a realistic motion of the judge. And we also explored the use of speech recognition through a module called React Speech Recognition in order to either extract keywords or detect pauses in the student's speech. And Michelle, our other developer, would be introducing you our Moot Court app features.
Thank you very much. So in terms of the Moot Court app features, students are able to switch the judge skins and the voices available. And this is done using the Leva menu on the left of the screen. There's also the option for subtitles for those who are hard of hearing, and this will help with accessibility. Some newer features that were implemented was the ability to customize the judges' questions. So as of now, we have generic questions that are typically asked in a moot court, but students can also input their questions that they created themselves, and whether these will be randomized or asked in a sequential order. In addition, there is a timer component in the scene. So in the menu, you're able to talk about the length of the entire moot session and when the warnings are available. And these warnings will be shown through the change of color in the circle beside the timer. And in addition, if students have to leave at any point, they have the option to pause the Moot app entirely. So this semester, we wanted to focus on giving students control of their own mooting experience. So they were able to customize the timers, including how often judges speak, how long the entire presentation is, and the warning times. In addition, through the menu, they're able to adjust the judges' questions and how frequently they are asked and what questions they will be asked. In addition, last semester when we were trying to decide on the animation for the judges, we used Deep Motion to generate both the models and the animations. Although this semester we optimized animation processing times through a pipeline using both Deep Motion, Mixamo, and Plask AI for smoother loading times.
And in terms of additional content, since Moot Court is a learning experience, the additional resources given include both the typical experience for first-year Moot students, criteria for self-reflection, and formal etiquette, including dress code and typical procedures.
So since our project is quite new, here are some possible next steps for our development side. So first, we would like to optimize the speech synthesis and connect the customization interface to the presentation components. And we also would like to introduce the multi-user server, which would enable the students to ask questions to each other through the internet. And we also want to look more into speech recognition to detect the speech of the student using the application.
In terms of design and implementation of new functionalities, we were kind of in the works for, like Rosalie mentioned, a multi-user function where students can message each other a set of questions that they have, and then automatically we can copy and paste that into our setup page, and then they can practice the questions that their peers have also set up. And then we will also be, we are planning to do some full-scale user testing. So that means with our current version, we want to test our application to see if there's anything we need to work out. So full-scale user testing would be from seeing them use the application to gathering some qualitative data with that. So thank you for listening.
Thank you so much. Okay, thank you so much to the Moot Court team. So that concludes all the presentations for today. But before we dive into the Q&A, we're just going to hear from EML faculty in residence, Dr. Patrick Pennyfather. He's just going to say a few words.
Thanks, everyone. I've timed myself for 4 minutes in case you need to go. Here's the timer. I'll try to be brief. Thank you, everyone, for being here today. My name is Dr. Patrick Pennyfather, and I'm a faculty in residence at the Emerging Media Lab. Welcome to those joining us remotely as well. I'm here to hype a course. I'm here to hype a course that Kevin Fisher has been a client partner with as faculty, as well as David Gardner, as well as Dr. Tom Schulte from Theater and Film. This course is called Collaborative Prototyping. As a student, you are welcome to enroll in this course in Winter 1 or Winter 2, fall semester, winter semester, language. Anyway, this is a course that is about developing proof of concepts for small scale faculty, and what's new this year is industry proposed projects. So right now on the lineup is Renaissance Opera as a client partner, as well as Departure Lounge and Christ Immersive as a partner, as well as UBC Libraries working to develop different types of prototypes for the Shakespeare folio. And I think I might have convinced John in law to also come on board. Are you confirming that with a hand up yet? Yes! So if you want to learn about different practices of prototyping, if you want to learn about Agile, and if you want to learn how to work with others on a project-based course, then join up for the Collaborative Prototyping course. You can quiz me after on the types of skill sets that you need. We are pretty open to whatever skill sets you come to the table with. These are interdisciplinary teams, and our goal is to give you a taste of collaborative projects that then extend into the Emerging Media Lab. So this course is in cooperation with the Emerging Media Lab, and I'm super excited to offer this course. Welcome to it, and I welcome any questions following. Thank you so much for your time. That was 2 minutes and 15 seconds.
Very fast.
Okay, thank you so much. So now we're going to have the Q&A session for all of the project teams. So please feel free to just raise your hand and I'll call on you and you can direct your question to any project team. Also, if you're joining us on Zoom, you can put your questions into the chat. I think there was a few already, but if anyone has any on there. Yes.
Good question. Someone put in chat saying, Patrick, what is the course code for this? Yes. Later on, I guess. Yeah. Okay, TR399E. Okay. Okay, there will be more information on the website about the course.
Great, thank you. I think we'll bring it back to you, yeah?
When you were describing, okay. Test. Yeah, so I have a question for the Moot Court team. When you were describing the project, I think there were a couple times where you mentioned laptops. And so my understanding is the application is primarily designed to be run on a traditional display, but it seems to me this is a use case where virtual reality would really blend well because it's so much more immersive, and I guess the idea is to immerse the user. So I was wondering, is there currently VR support in the Moot Court app? And if not, is that in the roadmap for the future?
It's a great question. The issue is this is a practice tool, and students in a real Moot Court have notes in front of them. So what we would have to do is find a way in VR for those notes to be available. And so I do think it's on the path, but it's not a simple problem because even in a real Moot Court, you're not going from memory. You're going from your notes. Oh, Nico has something to add.
One thing that was actually beneficial of the laptop, it is when you're in court, you're at a podium and you see the judge. So we actually like what the screen created. It was that view of the judge. So we thought there may be some more steps to it, but we really liked it was putting the student at that podium, the same perspective they would have in the actual court.
Thank you so much. Oh, do you? Oh, yeah, of course. Here.
And this is to any of the groups. One thing we did some user testing, which is really useful. We found it very difficult to get students not only to do it, but to actually fill out the things and so on. I was like calling in favors from students. Remember I wrote you that reference letter 2 years ago? Come on, come and test this thing out. I'm just wondering if you guys used any particular procedures or incentives to get students to actually come and do the testing and fill out the questionnaires.
Was that directed towards the...
But I don't think we told them that ahead of time. We give our users gift cards to thank them for testing our tool. Can anyone else remember what the gift cards? They might have been Amazon. I feel like we wanted to avoid Amazon, so maybe it wasn't Amazon. I can't remember.
Great, okay, so maybe we'll just take a question from Zoom. So do you want to read that?
So Joel asked, prior to these projects, how familiar were the students and staff for that matter with programs like React Refiber, Leva Control, Unity, etc.? Oh, how familiar were the students with programs such as React Refiber and Unity?
I joined the 3D Metabolism and we use Unity and C#, which I had no knowledge of before I joined the team. So I think, and I think that's the case for a lot of EML students that, like the student workers that join EML, is that you don't necessarily have the specific technical knowledge, but all you need is like kind of be open to learning more, and it's kind of like enthusiasm. So like almost all the student workers here that I've worked with myself, like I think we all learned something along the way. I'm not sure if anyone wants to add anything more, but.
Yeah, so most of the students, especially for React 3 Fiber, because it's not commonly used, we mostly had to pick it up on the spot. I think the good part about EML is that although we are creating educational products for the PIs and the students, the creation process for the student workers that work here is also a learning process. We pick up a lot of skills, and EML also has basic introduction courses for Git, which is the like tracking tool that we use, as well as Unity and Blender, which are the modeling and VR application creation tools that we use. So yeah.
So I guess like I think like normally we would expect that you need to like know enough about tech to join, but my major's in theater. It's completely different, and I came in with like basically like no knowledge other than after taking Patrick's class, theater 399E, I think, perhaps, it might change according to Patrick, shout out. So like in that course, I kind of just, like most of the stuff I learned from that course kind of gave me like a smoother transition into working at EML. I was like less clueless of like what's going on. So yeah, I guess like, because this is like, this is still within like the framework of like UBC, which is like a place to learn. So I wouldn't necessarily say you need to be like the strongest in any of the aspects that like you, like tech or design, because I learned most of those during my stay at EML. So yeah, don't be afraid, don't be shy.
I guess that's it. Yeah. I could also add on to that answer and saying like the main goal of EML is like not only to make cool stuff and help like push the limit of technology, but it's also to just like learn a couple of things on the way and just kind of just get better at those skills as you come along. It's also about becoming a good team player as well. And I guess that concludes our Q&A. And I guess in general, that concludes our presentation. Oh, sorry.
Just a question for the Geospatial audio group. It sounds very, very cool. And I'm just wondering, you mentioned the app that you're developing. Is that likely to be something, once you're through the proof of concept phase, something that you would make available to others on campus so that they could also use that platform or that app? Because I could see a lot of applications.
Thank you for the question, Duncan, and nice to see you. Yes, so this is the project that we're hoping to make broadly available to the community. So what really this project was two different things, right? We have the Musqueam street sign project, which is an end user case, and then we have the what we're calling the authenticated user case. So with that case, yeah, you would be able to work with your students from Land and Food Systems and create similar place-based audio pieces on there. So, and with Cedar as well too, that we have space and capability to help with that. So yeah, we would love to see you and your students working with this once we get it up and running. Thank you.
Okay, so I think we're going to wrap up the Q&A. If you have any more burning questions, you can definitely direct it to the project team after.
And if you're interested, there's a number of ways you can get involved with EML. For students, for students, we are currently seeking volunteers for summer 2022 or to join our student group, EMLX, where you can work on your own projects. For faculty, we are accepting project proposals for the September 2022 to April 2023 terms. If you would like to know more about getting involved with EML in general, you can find more information on our website, eml.ubc.ca, or feel free to ask any of us about anything.
Yes, thank you so much to all of our amazing presenters and to everyone for coming out today. We really appreciate everyone's support. So now we're all going to be heading down to the second floor for the live demo portion of the event. If you'd like to start making your way there, And thank you so much again.